All right, today we're looking at other types of radical equations. So on example number 1, you'll notice I have a cube root of x plus 6 equal to 2 cube root of x minus 1. If I've got two roots that are the same type of root, same index here, on either side of the equal sign, to solve, you're still raising both sides to the power of the index. So on this one, if I raise this to the third power, raise this to the third power, what happens on this side on the left is the cube root and the cube cancel, so I've got x plus 6. Now on this side it's not quite as simple. You've essentially got 2 to the third power and then cube root of x minus 1 to the third power. So the cube and the cube root cancel here, but I do need to do 2 to the third power. 2 to the third power is 8, so this would be 8. And then x minus 1, and you have to be careful because that 8 needs to be distributed inside. So you would have x plus 6 equals 8x minus 8. So then to solve, you would get variables on one side, constants on the other. Because I want to get a positive variable, I'm going to subtract x. Okay, so I've got 6 equals 7x minus 8. So add 8. I would have 14 equals 7x. Divide by 7. I get x equals 2. Okay, and of course, as usual, you want to plug the 2 in for x on both. So on this one, what I would probably do, you've got two cube roots you're going to have to deal with. So here you had on the original problem it was cube root of x plus 6, so x is 2 plus 6, well you should be able to do that one in your head, but nonetheless let's keep going, equal to 2, and that should equal whatever 2, math, cube root x minus 1, so that'd be 2 minus 1 should equal 2. So they should equal each other because that's what the original problem said. So they both equal 2. Okay, you just want to verify. So example number 2 is quantity x plus 6 raised to the 1/2 power minus quantity 2x minus 4 raised to the 1/2 power equals 0. So on this one, I've got 2 raised to the 1/2 power. That essentially means square root. So square root x plus 6 minus square root 2x minus 4 equals 0. Okay, because if I square this side and then square this side, I'm going to have to FOIL. This is ugly. This is a binomial. I would have to FOIL. I would not want to do that. I want to move one of the two of these to the other side of the equal sign. Since this one's already negative, I'm going to move that one. So if I add square root 2x minus 4 to both sides, is what you're doing. Those obviously cancel. You've got square root of x plus 6 equals square root of 2x minus 4. And then you would want to square both sides. So square both sides, you get x plus 6 equals 2x minus 4. And again, because the bigger variable's on this side, I would subtract x, gather variables on the right. You get 6 equals x minus 4, add 4, you get 10 equals x, or x equals 10. I would actually prefer you rewrite it x equals 10. Okay, before you box it, you want to plug that into the original equation. Make sure it does equal to 0, which it does. I'll just save time. But on the assignment, you'll have to actually check for yourself. Okay, I have one more example that kind of gets fun, so you know what? I'm going to go ahead and flip over. That way I have plenty of room to write. So number 3 is cube root of 3x plus 3 minus 1, which is not in the cube root, equals x. So on this one, I only have a single root, only a single radical, not radicals on both sides. So this is kind of similar to yesterday in that get the radical by itself, so add 1. If I add 1 here, I can't combine it with x. 1 has an x, 1 doesn't. Can't combine them. So that means I'd have cube root 3x plus 3 equals x plus 1, because those cannot be combined. They're not like terms. So on this, to get rid of the cube root, I need to cube both sides. So this is going to be fun. You already can probably see. The cube root and the cube cancel. And that's going to be 3x plus 3 equals x plus 1 times x plus 1 times x plus 1. Oh yes, that's what that meant. That meant I have 3 x plus 1s. So I've got to FOIL twice, or FOIL once and then distributive property second time. So I'm going to drag this down. 3x plus 3 equals FOIL. First, x squared, outer, 1x, inner, 1x, last would be 1. Okay, so that's that times x plus 1. Before I distributive property with that, I would combine your like terms. So I'm just dragging down the 3x plus 3 equals. This becomes x squared plus 2x plus 1, all times x plus 1. So I'm going to multiply my x through first. So this is 3x plus 3 equals x cubed plus 2x squared plus x, because I multiplied x times all of these. Now I've got to multiply 1 times all of these. So that's just going to be x squared plus 2x plus 1. And then I need to combine like terms. So 3x plus 3 equals x cubed plus 3x squared plus 3x plus 1. Because this and this became that, this and this became that, and then plus 1. So now I've got a cubic equation. We know how to solve these. It's been a little bit, but we know how to solve them. I need to get the equation equal to 0. So I need to subtract the 3x from its like term. That would be this one. I need to subtract the 3 from its like term. That would be this one. So here these cancel. I've got 0 equals x cubed plus 3x squared. Oh, looky what happens here. Those cancel. And then I've got minus 3. Okay. So on this, oh, minus 3, minus 2, hello. Okay, so on this problem, I've got a cubic that I need to solve. This isn't something I can do by grouping, so it's not 4 terms. I can't solve it by grouping. It's not quadratic. I can't use quadratic formula. So what I'm going to refer to is that 8-7 video that we did, Fundamental Theorem of Algebra. There should be 3 solutions. But in order to find them, I don't really want to have to do the cubic formula. It's kind of a beast. I'm sure I've shown it to you. So I'm going to utilize my technology. I'm going to plug this in. Oops, it'd help if I put a plus. I'm going to plug this in the calculator. And I'm going to look to see if I can find any x-intercepts easily. Okay. That's not an even number. That might be -1. That might be +1, but I don't believe it is. So let's use our table to double verify. So I thought it was -1 or +1. I really didn't think it was +1, but yeah, the -1. Okay, so -1 is an x-intercept. So you remember this. Take that root of -1 and divide it out using synthetic division. So I would have 1, 3, 0 as a placeholder for my x term, -2, and then just start going to town. So this would be 1, this would be -1, that would be 2, that would be -2, that would be -2, that would be +2. As we expected, the remainder is 0 because -1 is a root. So far I have x equals -1 as a root. Okay, that worked out. And then here I'm left with a quadratic. It started cubic, now it's quadratic. And I could do quadratic formula because the other two were not whole numbers, so we can probably guess that they're irrational solutions. So quadratic formula says I take this guy, it'd be opposite of b plus or minus b squared minus 4AC all over 2a, that'd just be 2. So this equals negative 2 plus or minus, if I put that in the calculator, I would get radical 12 all over 2. Okay, your work with this lately, especially a lot lately, would be that 4 times 3 is 12. The 4 is a perfect square. It comes out. So this would be negative 2 plus or minus 2 radical 3 when you simplify all over 2. Both of these are divisible by 2. You could do it by factoring out the GCF or just noticing that both of those are divisible by 2. So this would be negative 1 plus or minus square root of 3. So there are your two other solutions right here, negative 1 plus or minus square root of 3. Definitely want to write them all together. And because it was cubic, I should have 3 solutions. I do. In order to double verify, you would want to plug these back into the original equation, make sure that they all work out, and you would be good to go.